Over the past year, our team set out to answer a difficult question. How can we make cutting-edge robotic learning accessible not just to well-funded institutions, but to everyone? Today's robotic learning methods are powerful, but often inaccessible. They require large datasets, expensive hardware, and advanced technical experience. These create inequities in who can participate in robotics research and who can contribute to the next generation of intelligent systems. Our project set out to change that. We aim to build an open, transparent, and efficient framework that lets students and researchers train robotic manipulation policies rapidly, with minimal data and computation. We began by extending Searle, an existing open-source platform for real robotic reinforcement learning. Our team injected symmetry-based learning tools, improved data efficiency, and added modules for learning from demonstration. We validated everything in simulation and on the real robot, showing faster, more stable learning. These tools now live openly on GitHub, reproducible, transparent, and ready for others to build on. These strengthen trust and reduce the gap between high-resource and low-resource institutions. To support new learners, we created a comprehensive library of open educational resources, tutorials, theoretical notes, system guides, and algorithmic walkthroughs. These live on our openly accessible website and help students from any background gain confidence with advanced robotic techniques. This emphasis on accessibility, clarity, and inclusiveness ensures that more voices can enter the field and thrive. Throughout the project, we hosted 5 hands-on workshops, 2 in July and 1 each in September, October, and November. About 50 students from Lipscomb and MTSU attended at least one. These workshops were more than a training event. They were community building spaces. Students collaborated, asked questions, and even taught one another. Several workshop attendees joined our undergraduate research lab, strengthening diversity, mentorship, and long-term engagement. Our project emphasized transparency and reproducibility so that anyone can retrace, audit, and extend our results. But we also learned that simply publishing open source code isn't enough. Students need encouragement, vision, and belonging. As robots trained in the lobby week after week, new students stopped by, curious, excited, wondering if they too could also learn this. Many did. By lowering technical barriers and raising human connection, we fostered a culture of trust, equity, and collaborative growth. This project is only the beginning. We hope to continue refining the framework, creating richer learning material, and inviting even more students into robotics research. Our goal is a long-term ecosystem where open science fuels both innovation and opportunity. We extend a heartfelt thanks to the Open Research Community Accelerator, ORCA. Their support gave us the vision, resources, and encouragement to pursue open, equitable robotics research. This work has reshaped how we think about accessibility and impact in AI, and we are eager to continue building on this foundation.